Hello learners, today we'll be solving question number 7 on the A-level pure mathematics paper 4. So the first part of the questions that we are asked to complete, we are asked to write 3x minus 1 over x plus 2 as a plus b over x plus 2. And then a and b are the constants to be found. There are two different ways, the methods that you can do this. The method that we use in the partial fraction, the method that we use in the long division. So I am in this video going to use long division. So the fraction is 3x minus 1 over x plus 2. So basically that tells us the 3x minus 1 is going to be divided by 2x plus 2. So if you know the long division, that's also called polynomial long division, you already realize that we need to get rid of 3x first, because the fraction, the division, or that's only possible as long as the numerator, let me put it in this way, numerator has a degree, it's either the same as a degree of denominator or bigger. Okay, so we need to be taking this all the way to the point where the part, or we're gonna call it remainder, let's say has a degree that less than the x plus 2. Okay, by the way, x plus 2 has a degree 1. Okay, so to do this, we're going to be multiplying x plus 2 by 3. That will be a 3x's and plus 6. And then just like you did normally in the long division, you should be minusing this. 3x minus 3x will be 0. Negative 1 minus 6, that's going to give us minus 7. So as you can see, the degree of 7, and you can just, let's write it as an x to the power of 0. So degree of 7 is 0, or degree of this polynomial, let's say, is 0. So that means we're going to be stopping this process, okay? Stopping the long division. So now at the end, I'm going to be writing this as 3x minus 1 over x plus 2 is a, which is 3, minus the remainder, we found it as 7 over x plus 2. This is the form they want. It completely matches what they have. So there is an a over here and there is a b on the top, x plus 1. Okay, so to put a plus sign over here, don't get confused, or just like don't think that I did something wrong. This negative sign can be written also as like plus negative 7, like negative 7 can be written on the top. So I can't say now a is equals to 3 and b is equals to negative 7, not necessarily. So we found the answer for that. Okay, then the next part says the finite region R shown shaded in the figure 4 is bounded by the curve, the line with the equation x equals to 4 and the equation with the y x equals to 1. So it's talking about this and then this. Okay, so that's like this region R is bounded with this two vertical equations, like x equals to 1, x equals to 2, x equals to 4. This region is rotated through 2 pi radian about the x-axis to form a solid of revolution. Use the answer to part A in algebraic integration to find the exact volume of the solid generated, giving your answer in the form of pi times p plus q ln 2, where p and q are rational constants. So that's given in the booklet also. Like I'm talking about the formula, and I'm going to write the volume of the shape that revolves around the x-axis is pi multiplied by from a to b y squared dx. Okay, so pi stays there, so the integral is going to be from 1 to 4, as you can see this from the picture, but it revolves around 1 and 4 and it creates a solid 3D shape. So from 1 to 4, and a y square, so the y we have is on the top. Let me write there as a y. This is the y, and I can obviously take this one and square it, or take this one and square it. So we have to be taking this one to square it and then solve this one using is because if I square this, the result from that is easily going to be integrated. Okay, so gonna be taking 3 minus 7 divided by x plus 2 all together squared and then the dx. Okay, so pi stays there, 1 and 4, and I'm gonna be squaring 3 minus 7 over x plus 2 squared. That will be 9 minus, so I'm using a polynomial identity. 2 times 3 times 7 over x plus 2 will be 42 x plus 2, and plus 49 out of x plus 2 altogether square. Basically altogether 7 over x plus 2 altogether square. So like 7 squared is 49, and then divided by x plus 2 square dx. So pi stays there, and 1 and no, actually let's get started integrating already. Okay, maybe just wait a minute, and then gonna be showing you a couple of things. So 42 out of x plus 2, let's keep it as it is, but we are going to be writing this 49 out of x plus 2 squared as 49 times x plus 2 to the power of negative 2. So well, that's gonna be easy for everybody who's watching this video. It's just like how to find the integral of 49 over x plus 2 squared. Okay, so now all we have to do is we have to be integrating 9. Let's put the pi here. 9 integrate 9x, and then minus 42 ln x plus 2. So like 1 over x is ln x, integral of 1 over x is ln x. Hopefully you just know this already. And the other one, I want to do it directly to make this video short, but you can write all the process like when you find the integral of x squared or x to the power of negative 2 dx, so you just say it's x to the power of negative 2 plus 1 over negative 2 plus 1, right? Blah blah blah. So that's what I'm going to be applying to this expression then. I'm going to have minus 49 and x plus 2 to the power of negative 1. So negative 2 plus 1 will give us negative 1, and divided by negative 2 plus 1, which is negative 1. And then negative 1, 49 divided by negative 1 is just a 49, okay? A negative 49. From where to where? From 1 to 4. Alright. So now carefully we have to put 4 instead of x and put 1 instead of x, and then subtract the values. You might need a calculator for this, and just subtract it, and then like get the final answer. And don't forget to write it as they want, like they want in the form of pi times p plus q ln 2. So 9 times 4, 36, minus 42 ln 6, minus 49. 4 plus 2 is 6, so it's basically 49 over 6. Okay, so the next step, I'm gonna be taking this a little bit up. Okay. All right. So the next step is to put the negative and to put the 1 over there. So that's gonna be 9 minus 42 ln 3, 1 plus 2, and minus 49. This time divided by 3. Okay, it used to be 6, now it's 3. Okay, so let's just start simplifying that. That's going to be a 36 minus 42 ln 6 plus 49 over 6. Yeah, I mean minus minus 49 over 6 minus 9 plus 42 ln 3 plus 49 over 3. Okay, keep the pi there, and then 36 minus 9 will be 27, and then so basically these are used. Let's highlight this, these are used. Okay, so then I am going to minus 49 out of 6 from 49 out of 3 using a calculator. 49 out of 3 minus 49 out of 6, so that's going to give us 49 out of 6. So that will be plus there will be a plus 49 out of 6, and then a 42 ln 3 minus 42 ln 6. Okay, so all we gotta do, add 27 to 49 out of 6. So the answer plus is 27, and that gives us pi times 211 over 6 and plus 42. So you know that 42 ln 3 minus 42 ln 6 means 42 ln 3 divided by 6. 3 divided by 6. So I can write this 3 divided by 6 now as an half. Okay, so remember they want it as pi times p plus q ln 2. It's almost the same, but there's an exception. They have 2 here, but we have an half. That's not a big deal, because we can write this as 42 ln 2 to the power of -1. So this is the final. I'm going to be doing now 211 over 6 minus, this minus 1 comes to front, 42 ln 2. That's exactly how they want it. That's it.